Good morning, good afternoon, everyone, wherever you may be joining us from. I want to thank you for taking the time to join me for an IV6 system overview. My name is Dave Howden. I'm Technical Services Manager for the Loudspeaker Solutions Group here at Biamp Systems. Going to go through a few installation examples first here, just to show you some pictures to get an idea of what sort of installations you should be thinking about as we go through this overview today. First installation we have, it's a worship space. Looks more like a standard auditorium. We have two IV6 systems left and right, 6 elements each. Flown to the ceiling, and also had a center fill in this system. Another worship space where we used a smaller IV6 array system, 3 elements each, left, right, focused inward somewhat to keep the energy off the walls. Yet another worship space. Bit deeper space, a little more acoustically challenging. This one actually has the IV6 118 subwoofers nested at the top of the array, and looks like 6 elements down low. And another larger worship space, with balconies, still using a single array to provide coverage for the lower and the upper seating. There were delays installed in this system for the under balcony, but we've got a left-right array and then a central array that you can sort of see in front of the structure. This is a high school auditorium. Again, 6 elements hung left, right. This one was dropped down with some polar focuses, more customized software in order to achieve the aiming and keep a clean looking installation. And another very similar auditorium, although this one, if you look closely, you'll see there's actually subwoofers behind the IV6 array, which is one of the options with our sub-behind frame that we offer. And another similar auditorium, again, subwoofer on top, 6 elements, dead hung from a single point, left and right of the proscenium. And a little bit smaller space, local to us. If you're ever, out in this area, would be happy to bring you to have a listen to this 5-element array. And this, it's about a 350 seat performance space. Does anything from from comedy to full-on music. For this system, due to ceiling height limitations, we actually placed the subwoofers on their sides in front of the stage and did a bit of beam forming for the low frequency by applying separate delays and band passes to the subwoofers on the floor to focus the energy into the audience area. And this also is a system that's very local to the community factory. Also, it's a local park. We'll look at this system in a little bit more detail later, but this is obviously the outdoor versions of the IV6 systems, again using custom polar focus rigging. It's projecting about 30 feet, 30 feet deep up a sloped hillside, and or 30 meters, 100 feet, and then about 2.5 times the width of that for this little amphitheater. And one more small performance rig with customized rigging for live band performance in an outdoor venue down in Texas. Indoors, things certainly get challenging. This was a bit of a challenging acoustical space. It's used for both the worship space on Sundays and as a multi-purpose space the rest of the time. We used I think it's a 9 or 10 element array flown in the center to project the depth of the room, which is about 60 meters or almost 200 feet in this space. We actually went and commissioned this one, and it sounded very good in the end. Customer is extremely satisfied. So these systems are very scalable depending on the needs of the space. Challenging spaces, longer arrays are always going to work better, give you higher directivity, and help you combat some of the room acoustics, as much as we can at least. This is another example. This is actually a temporary outdoor system that's put up in Belarus for a couple of weeks a year. Obviously, an outdoor system, and yeah, lives outside. Our outdoor systems are designed to just be left outside, forever, 365 days a year. But this is a temporary installation that's taken in and out. And then another installation, which turned out to be a temporary installation for a gala show in China, which they were very, very happy with the performance of the system. So let's get into some of the nuts and bolts of it. Again, my name is Dave Howden. There's a question box down in the lower right-hand side. This presentation is being recorded. If you have questions, feel free to put them in there. I'll answer them as I can, or if there's a lot of them, I'll gather them up at the end of the presentation and be happy to answer whatever I can for you. Okay, so the IV6 is part of our I-series system. The IV6, it's a high performance, high output modular vertical array system. In addition to the IV6, we also have our standard 12 and 15-inch two-way systems. We have three-way systems in a 15-inch flavor. We have compact systems, both 6 and 8-inch driver sizes, and we have a very wide variety of subwoofers to choose from, and all of this in 2 different power levels. We have our 600 power level, 800 series power level systems. So subwoofers range from a single 12 through a double 18, as I said, in 2 different output capabilities. But today we're going to be focusing on the IV6 system, which is a very scalable system that can be configured either as a line array, a constant curve system, or somewhere in between, or as we call it, an adaptive array. What really makes this system special and stand out amongst the competitors that have a 12-inch two-way passive system is our passive acoustic optimization, which really solves a lot of the shortcomings of most of the currently available on the market systems that are similar in application and purpose. These are designed for permanent installation. They're not a rock and roll cabinet. They're designed to go up once and stay up generally. We do have indoor and outdoor models with matching performance for the IV6 as well as the entire I-series, and these are manufactured at our factory in Chester, Pennsylvania. There's 2 different flavors of full range systems. We have our 1122, which is basically, it's a single 12-inch two-way, and we have a 5-degree vertical pattern, and we have a 15-degree vertical pattern to help us, build the wave front that we need. The system power handling is 400 watts continuous, 1600 watts peak, and each element is 16 ohms, which allows us to parallel a number of elements together. Low frequency output for these systems by themselves, pretty solid down to about 55 hertz. So there may be instances where, depending on the application, you don't need subwoofers. Of high sensitivity as would be expected, moderate SPL output as things go in line array type world. And both systems have a very consistent 120-degree horizontal dispersion. We use a single 12-inch ferrite low frequency driver with a 3-inch coil. High frequency, we have 2 HF drivers in this system, which are really just cruising. You know, we're really not taxing them at all based on the output requirements of the system. So we get very clean sound, very low distortion with the non-metallic ketone polymer diaphragms. We don't have the trade-offs with the system that you have with metallic-based diaphragms. So a much more pleasant listening experience, especially at higher SPL levels. We do have a subwoofer system which mates up same width as the 1122 systems. Again, a ferrite low frequency with a 4-inch coil, a very healthy 800 watt continuous power rating, 3200 watts peak. Goes quite low in frequency for a single 18, and its upper end range easily meets the IV6 full range systems with no problem. These are intended to go either in the array, behind the array, or as you saw, they could just be part of the system and on the floor, depending on the needs of the space. Sensitivity is about what you would expect, as well as a continuous maximum output number. So as we saw in the installation examples at the beginning, we really can scale this system for a number of projection distances or SPL needs. We could use in a kind of a standard constant curve array type system, 3 15-degree elements if we needed about 45 degrees of vertical coverage. We could also configure the system and as a standard line array using mostly 5-degree elements, or as we find ourselves doing quite often, we have more of a hybrid coverage array where we have a combination of 5-degree elements in the upper part of the array, and then the lower array you might have 1 or 2 15-degree elements to provide a wider vertical coverage angle for those listeners that are closer to the array and perhaps don't need as much SPL. So very versatile system, which allows us to achieve all of these different designs. As I mentioned, we do have 2 different horns. We have our 5-degree and 15-degree, and just taking a look at these plots without getting too deep into them here. We're showing in the top plot 45 degrees of vertical coverage with 3 15-degree elements, or 45 degrees of coverage at the bottom with 9 5-degree elements. Obviously, you'll get much higher intensity with the narrower patterns and longer array. But an important thing that this graph really shows in the similarities in the spectrograph is the the pattern control differences between the 15-degree and the 5-degree elements. They're very similar, which by design allows us to place a 15-degree, say at the bottom of an array, and still run it off the same amplifier channel, same DSP settings as the 5-degree elements, because the horns do behave so well and extremely similarly, even when you start mixing patterns within the same array with the same drive signal. So I've mentioned passive acoustic optimization, which is what really makes our system shine. Many competitive systems out there have the ability to you can attenuate the high frequency 3-6 dB, maybe a little bit more, but we've gone way beyond that in order for us to overcome those limitations. So passive acoustic optimization, or PAO as I'll probably refer to it from here on out, First of all, quick look at the back panel. It's what you would expect, for inputs. We can loop through on our NL4s. You also have a pass through on pins 2, should you decide to use those. Got screw terminals, NL4 connectors, as you would expect. Our individual element controls are what really enable the electrical part of PAO. This is basically our attenuation control for the individual elements, which is how we do our beam shaping passively. We can provide full cabinet attenuation in steps of 1.5 dB, from 0 dB up to 15 decibels of attenuation for the entire cabinet. This is accomplished through using a very high quality, high power autoformer, which we designed and we build. So it's an extremely good autoformer, and has almost no effect on the throughput signal, and has a high frequency extension and a very low saturation point for high power use. We chose to do this rather than attenuating all that energy into heat through something like resistors, which just wouldn't be a good idea in a system of this power level, especially at higher attenuations. We typically find that our bottom cabinet attenuations are, attenuation is somewhere in the 7.5 or 6 dB range, depending on the flown height. We can also independently adjust the high frequency attenuation in order to manage our SPL and our vertical beam width within a space. Altogether, there's 55 different combinations which can be selected, and no, you don't have to guess. I'll show you how we're helping you figure this out in Ease Focus 3. But this sort of flexibility, again, is one of the real differences between us and the competitors, and allows us to work so much better in these instances. As a quick example, here showing a 60-meter deep space, fairly large array, just to make the point. So with a typical system that doesn't have all the attenuation capabilities, all these PAO capabilities, if we flew a system and ran it off 1 or 2 amp channels with the same DSP drive, we're very loud, in the front, of course. The nearer rows are really receiving, too much energy, and we don't have enough energy towards the back of the space. Our energy is just not uniform. When we apply those filter settings that I just showed you, and through a combination of the coupler plates, which I will get into also, to optimize this array's angle and the splay between elements, we're able to get much more even energy, through the listening area, and we've attenuated down the closer cabinets passively. Again, we're just using one amplifier, single DSP processing for the entire array, and we're able to accomplish this, as opposed to an amplifier per cabinet or per 2 cabinets and different DSP on everything. Very efficient use of some good old-fashioned physics here. So looking at the difference before we applied PAO to the system that we just saw, we had up to a 15 dB difference at about 5-6 kilohertz. With the PAO applied, we really reduced the difference from first row to last row. All doing this just through passive attenuation and proper splay of the cabinet elements, of the array elements. So to make the point a little further, we're going to take a look here. Again, got about a 200-foot listening plane here, or 60 meters, just to make it easy to see. We can do just a constant curve system, which is fine for, short projection distances, smaller spaces, maybe places where you don't need as high of SPL. So we could use just 4 15-degree vertical dispersion elements if we chose to, if that works for our space. And that's honestly what a lot of our competitors are limited to with their simple but similar systems. We could improve upon this by removing 2 of the 15-degree elements on top and changing them out to 5-degree elements. We're looking from about 800 hertz to 5 kilohertz here in this mapping. We'll see that just by adding the 5-degree elements at the top, we're extending our coverage, deeper into the room. Still a little bit louder, but with a tight pack system, we're doing quite a bit better than we previously were. We can part of the PAO calculation is our adaptive splay, where we have either a tight pack, a 2.5, or a 5-degree splay bracket, which EaseFocus will calculate for you when you run that in the software. And we ran the Auto-Splay, and Focus suggested for us the proper splay brackets in between the individual elements. And you can see just by applying the splay, we're reaching about 30% deeper into the space again with relatively even energy, still from the same 4-element array, single amplifier drive channel. Now, if we apply those passive attenuation settings, our PAO that we looked at on the back panel there, we were able to attenuate the high level of energy in the front, so it's not just a hotspot, and taper the response of the array to provide us a much more even energy from the front to the back of the space. Yes, if this is a real system, we'd probably need some front fills or something like that, but for example purposes, it's just showing what we can do with just 4 elements, making full use of our PAO capabilities. So PAO, it definitely gives us a performance advantage over the competitors. 99% of them, just cannot do this. They're not able to produce that even energy field from the example 4-box array using a single amplifier channel. They generally require an amplifier per box to do this sort of work. So a minimum of support gear is required. One in the case of longer arrays, maybe two amplifier channels or bridge channels for a large array, but everything's running with the same DSP setting and the same signal. So that really minimizes our support gear and our overall system cost. All the elements receive the same DSP, whether it's 5-degree or 15-degree elements. If you look into SAR or the ALC library, you will see that there are DSP settings for 15-degree only, or a mixture of 5-degree and 15-degree elements, which is applied across the full range array. And we make this workflow, very efficient. For those of you that have used EaseFocus 3 or other AIMwares, it'll all seem very familiar. So let's take a look at the general workflow for, how do we get to these answers, and what sort of tools are available to us in EaseFocus 3 to help make the IV6, do what it does. So, 4 steps in general, very common. We need to lay out our venue. We do need to choose the appropriate number of array elements. You have to figure out, how much vertical coverage do we need for the space. Once we do that, we can auto-splay, which is part of the PAO process, and that will select our inner element plates, whether it's the tight pack 2.5 or 5-degree plates. those need to be ordered separately when you purchase the system. We have our rigging safety check module, which is a feature that hadn't previously been seen in East Focus before, where we're actually calculating all the static forces, and it will flag you if you're trying to do something out of the safety margin capabilities of the rigging software. And then we can run our PAO routine, which will provide suggested settings or profiles, if you will, for the attenuation on the back of each element. So, process that's very familiar: lay out your venue, put your audience areas in, position your array, get your trim height, to a height that is workable for the venue. Build your arrays. Again, need to figure out how much vertical coverage do we need, and select cabinet elements or a combination of elements based on that. Also, a pointer here, we really do like to put subwoofers into our full range arrays. A lot of times there's not floor space for them, but also getting a couple subs in the array does help with the PAO calculation for those attenuation settings. So whether you're using subwoofers in the array or you intend to put them on the ground, I'll suggest let's start off with a couple subs in the array to do the PAO calculation, and then you can reset it at the end. The routine works a whole lot better when it has full bandwidth, from 35 hertz to 16K, as opposed to just the full range elements. So we will then go in and tell which elements do we want to aim in our auto-splay function. This is very familiar for those that have worked with array systems in Focus before. Hit the auto-splay button. We could tell it which the upper box and the lower box that we are looking to affect, and we can also decide which audience areas we want to target. And East Focus will select the appropriate S1, S2, or S3 plates for us to use in between each element. And it's important to take a look at, do I have enough coverage? Do I have too much coverage at this point? Am I putting a lot of energy on the back wall? Am I still getting the first row? Maybe I have to, adjust my elements, more or less. Maybe I didn't put a 15-degree element at the bottom for the near field listeners, so I might swap it out from a 5 to a 15. But you have all those capabilities to do this. You can rerun this calculation until you have the correct vertical coverage angle for the audience area that you're trying to cover. So this is the mechanical part of the PAO. It'll select the inner cabinet plates, and they'll be listed here in East Focus. Our rigging safety calculator, we can put in what our desired safety factor is. I think it defaults to 10-to-1 safety factor for our system, and it's calculating everything from the rigging frame to the bottom cabinet, including subwoofers in the system or no subwoofers in the system. This is unique to the IV6 system. It'll certainly make the mechanical engineers happy. And this information updates automatically any change in tilt you make to the array or change in elements. It's constantly updating, and if you ever do violate one of the built-in safety factors or the safety factor that you chose, it will flag you, as there is a persistent status, and in the lower right, it will flag you if you're trying to work out outside of the parameters. It's the PAO part. This is a button you're not used to seeing in Focus, with filter settings, and then the auto setup. The auto setup, as I said, we this is what adjusts all those passive attenuators. We can select which audience areas we're trying to address. We hit the start button, and it will calculate and do a pretty darn good job of calculating the attenuation for both the full range and the high frequency on each element within the system. Again, I mentioned this PAO works a bit better if you do have a couple subwoofers on top of the system, which honestly you can go back and delete later. But what we have found just working with this a whole lot, put a couple subs in to start, and then just correct your hang height after you do this PAO if you need to delete them or you're not putting subs in the array. It just works a whole lot better that way when it has a true broadband signal to work with in Mapping World. We can go in afterwards if we start looking at our relative levels and our SPL levels and each individual element. We can adjust the attenuation of it manually if we need to tweak a dB or something. Maybe we decide we need to turn down the entire box. And you see these are all just in order. The box attenuation 3 dB, HF at 0, or -1.5, -3, -4.5. So you can go in and tweak them. Let's say the PAO process with subs in the array, I'd say it's about 85% correct. But in the end, you have to know how to design a sound system to use this. So go in and use your knowledge to, tweak this, look at your relative plus or minus 3 dB at 2K an octave wide and at 4K an octave wide. Go back and forth and make sure that it's being all that it can be. And again, you might have to tweak a couple, but we're getting you pretty close to the correct answer out of the box. As a quick example, the jumpers, this is something that the installers are usually going to do in the field. So send the ease focus report with them so they have all this information. This shows that we've got a box attenuation of 9 decibels, element 6 to be exact, and high frequency attenuation of 4.5 decibels. So what this tells us is that we move this jump, first we'd remove the 0 dB jumper, up here, but we'd take our cabinet jumper, move it to position B, and then it says single jumper position to 3. So we've got B and 3, which provides us 9 dB of full cabinet attenuation. And then the high frequency jumpers you see here, HF -4.5, just simply plug that in down there, and that cabinet is set, and you move on to the next element. So this is kind of repetitive, showing what happens if we had an A2 cabinet. We would move this over to the A position, and then locate this jumper in position number 2, which would give us 4.5 dB of attenuation, and we move our high frequency jumper down to -4.5. All right, let's talk about the frames. We're addressing the indoor flyware here. The systems are obviously available black and white. It's just designed and still manufactured by our friends at Polar Focus. It's a really, really neat rigging system that makes implementation and flying really easy for you. But we have anything from a simple single frame that can fly, full range elements. We have our GlidePoint array frame, our sub behind. Let's get into the details. So the GlidePoint array frame provides us infinitely, adjustability and aiming resolution. You can see across the top of the frame here, look to be numbers there. Yes, those are numbers, and these will, if you take the data from the ease focus report, it will tell you to line up the front or the back of the carriage with the appropriate number to get the desired down angle from your simulation. In this carriage, while it's the larger steel bar supporting all the weight, there is you see all thread here, which allows you to move the carriage back and forth just using a wrench, which also allows us to, even when the system is under load, already flown in the ceiling, if we decide we need to change the down angle by a degree or 2 degrees, whether it's up or down, we don't have to drop the array down. We can make these adjustments in the air while the system is under load without taking the array apart, assuming we need to just aim the entire array or slightly correct the entire array aiming. So a very neat, very wonderful time-saving feature of the GlidePoint array frame. And the GlidePoint array frame will support a combination of subwoofers or full range cabinets if desirable. You can see the weight limits to the left there and the capabilities of it. We also have a sub behind frame. It still uses basically the GlidePoint array frame in the front of it, which integrates very easily. We are able to provide independent panning and tilting of the full range array with the SBAF. We could put 900 kilos or 2,000 pounds of cabinets on this system. We can decide to create a cardioid array behind it if we choose to with our subwoofers. Our hardware does allow for that. But note that there is a downloadable separate rigging calculator to figure out the exact balance of these systems. It was a little too complicated to integrate into the EaseFocus software. So it's a separate calculator that downloads the IV6 package. With either one of these systems, you will want to order, and it does ship separately, the PY1 lift point, whether you're using a GlidePoint array frame or if you're using the sub behind system. And the reason we do make this an accessory is because our friends at Polar Focus offer a wide range of rigging options for depending on what type of structure you're attaching to. For your IV6 system. Anything from beam mounts, ceiling mounts, wall mounts, sloped wooden beam mounts, a lot of different options, and they attach in the same way that PY1 does, with a large carriage bolt through the top of the frame. So that's why we don't include it with it, because you may want to use one of these systems, or they may be appropriate for your install. The light array frame, the light array frame doubles as just that, a light, smaller array frame that will suspend up to 10 IV6 systems. It doesn't have all the aiming features of the GlidePoint. You can only get a limited amount of down tilt with this because we do not have rigging points that extend back behind the center of gravity of the system. So you'll definitely, in your EaseFocus project, if you plan on using this frame, you'll want to make sure you select this frame when you start building your array. It can also be used as a pullback bar. If you have a system that's being flown and it has a very extreme down angle, say from a high ceiling, you may just have to rig your steel in the front to 2 points and use a pullback point if you need to down angle further than center of gravity of the array will allow. The light array frame also allows some other accessories from Polar Focus, which we saw in some of those pictures, in order to attach to it, just to do some simple inward or outward panning of the array if you don't need an entire GlidePoint array frame system. So very, very convenient. It is notable you cannot attach subwoofers by design, to the light array frame system. So if you're doing full range elements only, it's a great choice. And it can also be a real cost saver too if you don't need all the functionality of the GPAF. We also have a U bracket that will attach to the light array frame. Should you need to, mount, a couple elements for fills, to a ceiling, or if it just makes more sense to fly it that way. We can combine it with our I-series balance point flyware. If you just have a central array and a couple of 12-inch or whatever systems projecting left and right to provide fill coverage as appropriate, yes, you can do that with the U-bracket. Maybe we need a rear fire. Maybe we're in a worship space and we need a little bit of general stage fill. We could also use the U-bracket there. And the U-bracket also allows attachment of our sub-behind rails from the I-series in case you decide you want to use a double 15 or a single double 18 element behind an array. So we have all these different capabilities with this system. The splay brackets that I've alluded to before, a bit more information, but I want you to take a look at the side profile view of this array first. This is actually with the covers off the side. There are wooden covers that go over the sides to hide the rigging. We decided to be kind to the installers and put a little handle hole here, just for ease of installation. But once you're done attaching your splay brackets, the wood covers go over the sides of the cabinets, and it's a very clean look, as you saw in the photos. The three different splay brackets, again, which Ease Focus will calculate for you. You can either get an S1, which is a 0 degree, basically a tight pack bracket, an S2, which is a 2.5 degree splay, or an S3, which is a 5 degree splay. They're powder coated aluminum systems, and they can be used indoors or outdoors, same SKU. We also provided some notches at the front. The notches always want to face forward, as you'll see in the IV6 manual, but to help the installers identify, is it an S1, is it an S2, or is it an S3? So when they're following their Ease Focus report, they get the array correct. Indoors, we have black or white as standard colors available for all three pieces in the IV6 series. Outdoors, the outdoor elements, they're available in black, white, or gray. The outdoor systems are constructed of our PolyGlas material, which carries a 15-year structural warranty to it, which is far longer than anybody else's warranty for their outdoor systems. 316 stainless steel internal rigging, marine grade aluminum grills, so they'll survive the harshest environments. You could put it in the Middle East, you can put it in humid Florida at a theme park. You could put these things on a cruise ship, or you could put them in a very cold climate. They'll survive because the thermal expansion and contraction of this PolyGlas material is almost zero, especially compared to people that try and take their wood cabinets and turn it into an outdoor cabinet, which generally does not go well, at least for not for very long. Our grills are powder coated aluminum. The PolyGlas material has layers of woven fiberglass mesh inside of it, and it's encapsulated in a polyethylene base substrate. Very, very durable and extreme, just great, great for the most extreme environments. We do seal up, of course, our PAO settings on the back and the outdoor elements, and we have a loop through gland nuts included with these to go from element to element, as we would still be running these in parallel. Outdoor systems do require custom rigging. There's a lot of things you need to consider, especially wind loading and these dynamic forces. So we really recommend that when you're putting together an outdoor system, that you're engaging with an appropriate engineer who can consider the various forces that may be applied to a system depending on its environment. Polar Focus, who designed the indoor flying hardware, also has some off-the-shelf outdoor flyware showing a couple of examples here of pole mount systems for 3 and 4. I actually used a 5 element, a 5 deep version of this at that outdoor park performance venue that I showed you. They've designed these outdoor mounts to survive, 110 mile an hour winds, which is 170, 180 kilometer winds, assuming the structure will take it. But we're not so much worried about the weight of the systems when we're placing these outdoors. We're worried about what sort of additional wind loading does it apply to the structure when a storm comes in. So please engage a professional engineer to evaluate any outdoor rigging and help make the right choices for it. So just some general guidelines: how many and which IV6 to use. We generally designers are with the standard 3-to-1 rule. D1 D2, distance from the furthest listener for the array, distance of the closest listener, will generally get you in the range of plus or minus 3 dB response, from first to last listener. So if I have an array, bottom of the array is 25 feet, I can generally project somewhere around 60 feet or 20 meters deep from that and maintain even coverage from first to last listener. But you can investigate this very easily in EaseFocus. If you go with a longer array, if you've got something that's on the order of 7 or 8 elements or about 3 meters long, you might get away with a 4-to-1 projection distance, but check that out on EaseFocus 3 as you design. We want to make sure that we can cover from the first row, whenever possible, to the last row without excessive energy on the rear wall. If you're seeing too much energy overlap in the side view of focus, energy back, and you can't aim the array down, maybe you've got too many elements. Or if you're lacking coverage in the front, in the first rows, and you've got all 5-degree elements, maybe you need to try a 15 degree or 2 15-degree elements at the bottom of the array to better cover those front rows. But as usual, keep energy on ears and let's keep it off the walls and avoid hard reflections from the back of a room. We do strongly suggest using at least 4 elements to create a usable vertical pattern for the IV6 system. I did show a couple of examples of 3-element arrays. Some people they want something that looks like a line array, and something that's 3 elements deep. It behaves like a line array in the high frequencies, but doesn't really give us the usable directivity below the voice band. But we can get away with it. But often, if we're doing very short throws, it's possible just a point source box, could be a better choice for those spaces, depending on the needs. But we try to do at least 4 elements deep. Usually find that 5 elements to 6 elements is kind of where you want to be. How loud can an array get? If we're looking at a 25-foot, 8-meter height above ears, 70 feet, 20 meters to the furthest listener, we could get middle 100s broadband with a fully powered 5-element array with no problem. And if that meets the performance goals of your system, fantastic. And we find that most of the applications that we're putting this into, the small to medium size, even on the edge of larger auditoriums or all hand spaces or outdoor venues, 5 elements is usually where we start. 4 15-degree elements and a 15, or 4 5-degree elements and a 15 at the bottom is usually a good starting point. And that will allow us to achieve middle hundreds in the back of the room after equalization. How far will it throw? Well, it's really a function of acoustics and required SPL. We got to balance the two. in general, we find if the room has an RT time, through most of the voice band of less than 2.7 seconds, an IV6 array certainly may be appropriate. If it's a very challenging, if it's a very challenging space or a place that just wasn't intended to do high-level, wide bandwidth playback, we just want to be aware of the acoustics and the potential impacts on intelligibility in those sorts of spaces. Well, the IV6 can provide a very good degree of directivity in the vertical plane. It's still a 120-degree wide horizontal system in the high frequencies, and we still must consider the intelligibility needs of the spaces and what the space will allow us to do. How many subs? We find generally for live music use, 1-to-2 ratio is very typical, whether they're in the array, behind the array, on the ground. 1 sub per 2 full range elements usually requires the required SPL. We find that in the smaller auditoriums, you saw some arrays with 1 and 2 subs in the pictures earlier on. 1-to-3 ratio, 1 sub per 3 elements will still provide, very good sound, very good sounding wide bandwidth reproduction when you're not trying to do a rock concert. The 118, it is an 800 watt RMS box, 3200 watt peak. Power those separately, obviously, from the full range elements, and power them per the spec sheet. So how many watts? How many watts do I need? So I've mentioned a couple times that the full range elements are 16 ohm systems when not attenuated. If you attenuate one of them 3 decibels, it turns into a 32 ohm system. And we're really just paying attention to, the full box attenuation here. So 4 boxes unattenuated, it's a 4 ohm system, and we suggest an ALC 1604D bridged to provide maximum SPL. I've had good luck using with 6 boxes with the lower impedance. The ALC 3202D can be a little bit of a cost saver if you don't need those last couple decibels of peak output. Single IV6 sub, a bridged ALC 1604D will give you full output from it, or you could use a 32OD bridged for 2 subwoofers, assuming you need every last decibel of output. We do have a downloadable array impedance calculator. This is in the IV6 package, and it will tell us, basically we can enter the number of boxes that we have in the array, and then we enter the attenuation setting for each of those boxes, and it will give us our nominal and our minimum impedance. And this is only affected by the full range attenuation of the systems. The high frequency systems aren't considered in this, so when calculating, look at your full range box attenuation and ease focus, and you can quickly determine what your impedance is, and help you size your wiring and size your amplifier appropriately also. I'm going to go through a few more examples here with a little bit more detail of IV6 systems. This is a flat floor assembly hall. The audience area size of 5, 10, 5, 10, 15, 20. It's about 20 meters deep for the listening area, about 15 meters wide. 2 arrays flown left and right of a stage. We're looking at the voice band here, about 500 to 5 kilohertz roughly. And you'll see we've got very even coverage, very little change in color, and we're right there in that middle 100 dB range in the voice band. If we looked at broadband, we'd probably add a dB or 2 to that. So this array ended up using 2 15-degree elements to provide coverage for the closer listeners, and then 4 5-degree elements to project to the back of the room. And notice in my side view here, I don't have a lot of energy beyond the last seat. I don't want it going against the wall back here. So my array tilt and my selection of elements are, focusing the energy. And if we look at a plus or minus 3 dB plot of it, you'll see that the energy cutoff at the last listener, very important to keep that energy contained in the seating area. And also you'll see here that I've covered my front row quite nicely also, and say very even SPL from first to last listener, which is always the goal. Let's take a look at a kind of a typical 6,000 seat sports hall. This hall could be, an ice hockey surface. It could be volleyball. It could, it could be a basketball court. But just a typical smaller sports hall. This one with the vaulted ceiling. And for this system, ended up being seven elements. Fairly high pick height. Our hook was at 43 feet or about 13 meters. And with the 120-degree horizontal coverage of these systems, it basically, took two elements on the longer side, two at the ends. And this one happened to have movable seating at one end of the arena. So it was a multi-function space. So a single array covered that. But you could imagine that if it was mirrored, we would have two arrays at this end. We were able to achieve this with six 15-degree elements per hang, providing good coverage from first seat to last seat, and not putting excess energy where it doesn't need to go. We still caught the standing room only areas on the back side here. And this system, if I recall correctly, ended up needing to use the light array frame as a bottom pullback point, just because the down angle needed for this system exceeded what we could do with the light array frame. So it was rigged from the back with steel and from the top also using the light array frame pullback bar. Here's the example I spoke of earlier at the outdoor performance space. It's about 200 feet or 60 meters wide and about 100 feet or 30 meters deep on a sloped hillside. See we used 5 elements of IV6 system in a custom polar focus rigging frame attached to these concrete poles, appropriately down angled. This system actually was incredibly easy to install. I was surprised, how easily it went together, as I was very hands-on with it, and the predictions, worked out absolutely perfectly. We've got a slight slope to our, seating for this listening area. The rise is about 4 meters from first row to last row, and 2 arrays splayed outward, basically dead hung at about 6 meters or 20 feet, facing straight out with a 15-degree element on the bottom, provided about 75% of the area with an extremely consistent listening experience. A couple hot spots here and there, but these cabinets are asymmetrical, so you will see that. But even then, we're just barely ticking plus 2 in these areas. So looking at the voice band here, it provided a very, very even coverage pattern and consistent cutoffs from the top edge of the listening area, the front of house mixing booth being here, to the sides to keep it out of the neighborhoods and contain our sound, because sound containment is always important outdoors. Not everybody wants to hear what's going on at the venue all the time. Well, that was a very quick run through of a whole lot of information on the IV6 system and some examples for you to keep in mind what sort of spaces we really target this system to. If you have any further questions, I don't think I'm really seeing any down here in the chat function. Feel free to email me directly at dave.howden@biamp.com, or you can always get support through support@biamp.com. Thank you very much for joining us for this quick overview, and appreciate you taking the time, and please be safe. Thank you, and have a great day.